Hello, so I'll try to explain some of the notes where we left off in class, and I'll try to answer some questions from the AP packet. And this was the last thing we mentioned in class, that any increasing exponential function will eventually outgrow any increasing polynomial function. And the difference between a polynomial and an exponential is quite simple. If your exponent is x, then that becomes an exponential function. But if the base is x, then that's just a polynomial. So the power is x, exponential. The base is x, polynomial. Power x, exponential. The base is x, polynomial. And you just want to memorize that the exponential will always outgrow the polynomial. And that makes a difference when you take limits at infinity. So I have 3 examples listed here, and we'll try each one. Example 1, the limit as x approaches infinity of x to the 5th over 5 to the power x. So if you were to plug in infinity, it makes no sense to plug in infinity because it's not a number, but this is what you would end up with. Infinity raised to the 5th and 5 to the infinity. And this is my polynomial, and this is my exponential. So, where will you have the larger number? It'll be the exponential. So that's where I'm going to decide to write down my infinity symbol. And even though infinity to the 5th power is a large number, because it's just a polynomial, it's not nearly as big as 5 to the infinity. So then I'm going to say that the numerator is just some random number, not big enough compared to the bottom. And from class, some number divided by infinity will give you 0. And so that's the answer to example 1. Looking over at example 2, I notice that I also have an exponential and a polynomial, but I notice that I have a negative exponent. So the first thing I want to do is make sure that my powers are all positive. So I'm going to rewrite the question and now try the limit as x goes to infinity of e to the x, and to turn x to the negative 2 into a positive exponent, I just need to move it to the denominator. This is from the laws of exponents. You remember those. And so there's a ratio, and there's my exponential, and here's my polynomial. And so where would infinity go? E to the infinity is, because it's the exponential, that's where infinity goes. And infinity to the 2nd power, because it's just a polynomial, even though again it's a huge number, it's just not as big as the numerator. And infinity divided by a number is just infinity. And when I'm talking about the limit, infinity is not a number, so then my answer is that the limit does not exist. And example 3, I also have a negative exponent. So the first thing I'll do is rewrite it and say this is the limit as x approaches infinity of x to the 30th power, that's a huge power, over e to the x. But again, which one will take over and dominate as x goes to infinity? This is just a polynomial. This is your exponential. So you'll have some number divided by infinity. And the answer will be 0 again. So that's the difference between polynomials and exponentials. Let me now try a few more examples. And now I want to have, I guess this is example 4. The limit as x goes to negative infinity of e to the 5x minus 300. And if you can again just pretend we could do this and plug in the negative infinity. Minus 300. I struggle with this pen. So e to, or 5 times negative infinity. 5 times negative infinity, that would just be negative infinity. Minus 300. And because you have the negative exponent, you want to rewrite it. So it's actually 1 over e to the positive infinity. But the 300 is not affected by that. And when you say 1 over e to the infinity, you're saying that's 1 over e times e times e, an infinite number of times. That'll be infinity. Minus 300. So 1 divided by infinity, that's 0. Minus 300. And so the answer is negative 300. And so even though most of the action was here, the math was happening here with the exponential, the constant is very important. You just keep bringing that down because at the end, that's what the answer was, the negative 300. It was not affected by infinity, and because your fraction became 0, then the constant became the answer. Let me try one more example. The limit as x goes to infinity of 37. What do you think the answer is? Well, we do have a property that says that the limit as x approaches any number c of a constant k is equal to k. So 37 is just a constant, and it doesn't matter what x is approaching. In this case, it's infinity. Well, the answer would still be 37. And it kind of makes sense, because when you look at the graph of just 37, what does that look like? If this is 37, y equals 37 is just a horizontal line. And so, isn't it true that as x approaches any number way out here, the y would still just be 37? That's what the property is telling you. I don't know how to get the AP packet questions here next to the slide that I'm working on. So I'm going to stop the video now, and I'll upload it, and I'll work on it on the AP packets separately. So I'll probably send you 2 separate emails, and this will be the first one, and the second one will have the AP packet information in it. Okay.